Welcome to EC Academy. Today I would like to talk about the computer science majors. Now it's again the season for college application. I know many students don't know what is the right major I would like to pick, especially in the computer science and the electrical engineering field. There are so many different kinds of majors, and which one should I pick? Computer science as a discipline, it actually needs a lot of mathematical background in order to support the computer science activities. And computer science, it actually can interface with many different disciplines. And computer science now, it has become a core knowledge that each individual needs to learn in their early life so that they can deal with problems in different application domains. And today, I would like to talk about what are these different disciplines in computer science and electrical engineering so that you know which major you can pick in the college. First, let me talk about the difference between computer science, computer engineering, and electrical engineering and computer science, EECS. What is computer science? Computer science is the science discipline that use computer to solve problems. So we have physics. Physics is also a science. For all science disciplines are using systematical knowledge to solve problems. So science is to solve problems. And then computer science is use computer to solve problems. And what are the problems that computer scientists have solved? I can pick an example. Basically, we may have a linear system, and then there are some criteria, set up a domain, and then we can set up a goal function, and that goal function can be a function f of x that equals certain ax plus by plus c. And this is a goal function. And based on that goal function, we try to optimize it. So a lot of time, the computer science is doing optimization to find the best solution. And this one, we can call it linear programming. And if the goal function is quadratic, say g of x that equals ax squared plus bx plus c, and we can call it quadratic optimization. So we hear the names dynamic programming, quadratic programming, linear programming, integer programming. They share the common goal to do optimization. And we try to find the best solution from the solution domain. So a computer programming is usually used to solve the problem and try to find the best answer. For example, we play Go game, and you put the black stone here, white stone here. So each time you have some black stone, white stone, black stone, white stone. And then we try to optimize the game based on which way you play. So we can call this one as a search tree, going into the solution space and find the best solution that represent a certain step that you should take. So computer science is finding the best solution and is problem solving. And what is computer engineering? Computer engineering, on the contrary, it is not to solve problem alone. It actually is a discipline to build computer. For all engineering discipline, it actually is to build something. So we have electrical engineering that build the electrical system. We have mechanical engineering that build machines. We have civil engineering that builds the residential area, build the public system, for example, transportation system, to build bridges. And we have chemical engineering to build chemical products, and etc. There are so many disciplines in engineering. And computer engineering is to build computer both software and hardware as a system. And then what is computer science and engineering? So basically, it combines the problem solving and build of a computer. Sometimes you build a robot to solve some problem. You build a drone to collect information to solve problems. You build a ATM to solve problems for financial systems. So the discipline of computer engineering is to build computers or computing devices to solve problems. And there are so many different kinds of the major in college. Here I picked the Donald Brain School of Information and Computer Sciences at University of California, Irvine. And this Brain School offers 8 majors: Business Information Management, Computer Game Science, Computer Science, Computer Science and Engineering, Data Science, Informatics, Information and Computer Science, Software Engineering, and also 6 minors: Bioinformatics, Digital Information Systems, Health Informatics, Informatics, Information and Computer Science, Statistics. There are so many different majors and minors. How can I know which one is my goal and which one actually fit me the best? And in the following slides, I will introduce these different majors. Before we jump into those majors, here I have some other disciplines. These disciplines are in electrical engineering. As you can see, it has the application domain in computer hardware, computer engineering, control system, image processing, speech processing, and bioengineering. And then in the middle, we have system architecture. You have computer architecture, information theory and coding, wireless communication, control system. And then you have the system verification technology. And then you have the physics layer, electrophysics. So these are different disciplines in the electrical engineering. To be short, the electrical engineering, we can divide it into 2 parts. Just like electricity. We can use electricity for representation of information. You can have high voltage or low voltage. And you can also use the electricity for power purpose. So electrical engineering divided into 2 major domains. The upper domain, we call it system. And system engineering usually to build information processing system. And something deal with the physical effect, we call it electrophysics. So basically, electrical engineering divided into 2 main disciplines. One is system engineering, the other one is electrophysics. And both are related to computer science. First, let's look at the system engineering. I picked the University of Southern California as an example. The system, we have signal and image processing, communication sciences, computer engineering, and control system, 4 major subfields. In electrical physics, we have energy, embedded system. Usually these are the IC technology, integrated circuit technology, photonics technology, quantum engineering, biomedical interfaces, RF antennas. MEMS, it deals with the sensor, actuator, resonator, and also many interdisciplines research themes. And in electrophysics department, usually it's like a shopping mall. There are so many store owners, and each one sell their own product. And then electrical physics department usually is like the shopping mall, collect all the store together into a shopping mall. Now, let me explain one of the major disciplines in the computer science, informatics or software engineering. What is informatics and what is software engineering? Usually we have a user, and this user will have interface to some system. So there is a designer called user experience engineer, help you to build up a user scenario. And then you build some software called GUI that actually help the user to get used to the system and knowing what are the scenarios that is supported by the system. And then for the GUI or the interfaces, we can have the software to do processing. And here we call it software. And then we have another set of the GUI that provide the result to the user. Again, it's related to user experiences. And to build this software core, we actually have something called software engineering. In charge of the software lifecycle, we call it software development lifecycle. And you can start from the requirement analysis, and then software spec, and then system design, and then coding, and then testing, and then integration, and then product release, and then maintenance. So the whole thing we can call it software engineering. And design of the user interface and the scenario for the information generation to the information usage, we call it informatics. So sometimes the software engineering department is also the informatics department, or the other way. So it really depends on which school named the department as informatics or software engineering. User experience. The user experience actually will deal with how user use the interface, and also the user's habit can be modeled into behaviors so that we can use the software system to help them. And the second one is to design the graphical user interface to support the scenario that we collected by the user experience engineers. Here we have some GUI designers. And then we develop the software system that support the interfaces, reports, data analytics, and scanners for the barcodes as well. And we also provide the version control for the software. So basically, at this stage, the software engineer may divide it into several disciplines as well, including the software integration, testing, software version control, tool development. And software engineering need to take care of all the development, testing, and release. Data science. Data science as a new discipline, it actually starts from the collection or sampling of the data. It can come from the business application, customer application, or some sensors. And then we have the ingestion to deal with the data for sampling, and then processing, preparation, and analytics to escalate the data into higher level so that the higher level manager can make decisions. And then you can see the data by visualization or searching for some result. And then we can provide to the user. So take one example. What is the major difference between Uber and normal taxi? Uber has the data sampling point from the cell phone. And then provide the information, go back to data center. And then it calculates the best result and then provide the information back to the cell phone. Taxi driver may also have the cell phone. It calls some call center and then arranges some car. So basically the major difference is right here, the data science. It provides quality data science software to provide the best match, lower cost, shortest latency. Again, it heavily relies on the problem-solving skill in computer science, optimization, artificial intelligence, machine learning that come in to help the optimization. And we will talk about these in later slides. But basically, the difference between Uber and the taxi is the processing center, data center. Otherwise, the cell phones are the same. Data science is a discipline between math and the statistics, computer science, and the domain knowledge. So domain knowledge is very important because if you don't know about the ecosystem of the taxis or cars, you cannot have a good system in the data science to help it. But you need to combine all the three different disciplines. So data science need to have the real-world application, data consulting, data research, data technology, statistical computing, statistical modeling, visualization, and scientific methods. It is a new discipline. And then you combine everything here together, neural computing using neural network, artificial intelligence, machine learning, pattern recognition, statistics, data mining, knowledge decision system, database, computer science. Computer science is the core. And computer science nowadays, including the algorithm, game, interface, AI, knowledge, machine learning, discovery, optimization, science, machine learning track, graphic tracks, system track, analytics, and security tracks. And what makes AI and machine learning different from the non-AI and non-machine learning system? Again, let's go back to our goal function model. We have our solution domain, and we have our goal function, and we try to optimize it. A non-AI system or non-machine learning system, these parameters may be chosen by some professor or some smart people come up with those coefficients. But this number may be not the best. So over the time, we actually throw in a bunch of data, and then we have machine learning to learn these different parameters so that it got updated. So we have an estimation system that keep improving these coefficients. So these numbers are changing. So it actually will be a day until a certain best goal function can be found. And same thing, these will be adaptive. Sometimes we can have different learning model in order to provide a better system. So this we call the machine learning system, and the whole thing for the learning and the making decision, we can call it artificial intelligence. This is a simple example for the introduction of machine learning and artificial intelligence. It may not be the complete view for these two fields, but I try to provide a very simple example to help you to understand what is machine learning and what is artificial intelligence. And the computer science have many core concepts: computing system, network and the internet, data and analysis, algorithm and programming, impacts of computing, the society issues, and also computer science, domain knowledge, and the mathematics build up the data science. And you can call all these as the discipline in computer science as well. And data science is one of the disciplines in computer science that will reshape our world. Thank you. Bye-bye.